We have around 34 people joined in, so I guess we can start.
Sounds good. Am I sharing the screen first?
Yeah, Anshuman, Saurabh, you guys want to kick it off?
I can share my screen.
Sure. Saurabh, do you want to make a quick introduction before we start?
Yeah, Anshuman, please go ahead.
Awesome. Firstly, thanks a lot to everybody who has joined in from different regions. Very excited to have you all here. So we have a very esteemed panel on the call who would be talking about different aspects of modernizing your business on cloud. We have Srinivas Makam, who is a customer engineer with Google. We have Reju Pillai, who is also a customer engineer with Google. And Saurabh Dubey, who is our partner engineer from Google, as well as Amarnath Bagineni, who is the lead for Apigee practice at Searce. So very excited, and thanks a lot, Srini, Reju, Saurabh, and Amar for making out the time. And over to you, Reju, to kick things off.
Thank you, Anshuman, and good afternoon, everyone. And thank you for joining this, taking time out, especially on a Friday evening. We really appreciate, and we hope that the session will be useful for you. So the agenda we have planned is for the next 1 hour and 30 minutes or so, and we will also have maybe a Q&A towards the end. But we'll start with the app modernization. What does it mean to do app modernization from a Google's point of view? We'll talk about the portfolio. We will also talk about what has latest releases that has happened with respect to the products within that portfolio. Srini will cover that. Srini will also cover some use cases of multi-cluster ingress and service meshes and policy controller. I will talk about serverless and maybe do some demos around it, and of course then we will talk about Apigee and Q&A. So that's what the agenda for today. So let's get started. So really, when I talk to customers about modern apps, or put it the other way, what do you mean by modernizing an application which is probably a legacy application? So every customer has a different perspective about modernization. So the way Google defines modern applications are certain attributes that you see here. So first is that a shift from a monolithical architecture, which is typically very heavy in nature, applications which are written 10, 15 years back or even before, things which run in silos and basically are very difficult to kind of move to a modern architecture. And so when you shift it to a microservices based, packaged in a container application, that's one thing that we consider modern app. Also, these applications or legacy applications typically run on a bare metal or a physical server, or if they are virtualized in, let's say, 10 years or so, when VMware and OpenStack and platforms like that had come, they also run on virtualized environment. So the shift to a container cloud native platform, so that's also another attribute of a modern app. So we basically expect that some of these applications will exploit the power that the containers can bring in, also the orchestration engines like Kubernetes, for example, or other platforms like Cloud Foundry or Docker Swarm and things like that, right? So those are the shift of the platform features that it provides to kind of orchestrate these containers. Along with these technologies, we also have some cultural aspect of how applications are delivered, right? A shift from a typical waterfall model or a spiral model that was kind of prevalent 10 to 15 years back has slowly moved into the practices of modern engineering best practices, put it that way, right? So how to do product development following an agile process. Maybe some of the customers use Scrum kind of a model, which is very popular, and also kind of build this capability of continuous integration, continuous testing, and continuous deployment, which kind of will lead you to a continuous delivery capability, right? So that you can release features into market often and with confidence. Of course, you practice DevOps, in this whole process to bridge the gap between the dev and the operations concerns. And one more important aspect of how Google defines modern apps is that it is heavily, a kind of advocate of open source, and we don't really, expect that customer need to sort of get logged into a particular technology or so. And Google has been a promoter of open source, and you will see in this slides also that we have actually a lot of open source technologies on which our app modernization portfolio is built upon. So largely you may be familiar with GKE, or the Kubernetes Engine, which is a managed Kubernetes platform from Google. But really, if you see, that is the infrastructure and the orchestration layer alone. And you'd probably be surprised to see that the app modernization portfolio is actually quite bigger than what you see in the orchestration space. So on top of GKE, and that is what that sort of Venn diagram that you see here, GKE is sort of encapsulated within the Anthos portfolio. So Anthos is our application platform for the hybrid and the multi-cloud space. So along with GKE, put on top of that a service management layer to so a service management layer to basically to kind of when the containers sort of talk to each other, you want to extract out some of those communications so that you can make meaningful insight of that. So things like, it's basically an implementation of Istio, and then we also have Cloud Run, which is the serverless platform to building web applications and other applications. Cloud Functions is another function as a service platform that we have. App Engine, which is kind of one of the very old, I would say, product that existed even before Google was, sort of Google Cloud was known. So App Engine was almost 10 years back. This product really came in, and this basically promoted the whole concept of PaaS, platform as a service. The whole idea about, hey, here is my code, go deploy to the cloud. I don't care how. So bring your code and take back home a URL, and I don't care rest of anything that is happening. So that's kind of the developers' concern was, because they were not really worried about much of operation side thing. So that kind of thing is what I think very early on Google promoted it. There are a few more technologies for orchestration that has more recently come. Event Arc and workflows are like January this year. That was G8, and we got also Hybrid AI, which is basically it's an AI solution that runs on-premise on Anthos clusters. There are also good news for the developers. I mean, if you are thinking that cloud is an operations play, that's not correct. So we have got a very good plugin called Cloud Code, which is available for both VS Code as well as for IntelliJ, and you can sort of connect the cloud services, whatever you're seeing, some of the services, and you can consume those things right from inside your IDE. You do not have to leave the context of the IDE. So that's other things like as part of the development process, you would create images, store into an image registry. So we have got a new variant of our container registry, which is called Artifact Registry. Now it not only stores container images, but also stores other artifacts like a library, like NPM or a Maven library, so that you can actually do your build. You don't have to store it somewhere else. Similarly, we have other things like build packs and migrate for Anthos, which is a tool that can help you convert from VM to container, and that runs on Kubernetes. So and on top of that is the API management layer. Create products, packages, subscriptions, split revenue, put constraints on how many requests per second you can expect, expose your services safely to B2B partners. So those kind of all things, both an API gateway as well as a full-fledged API management tool, runs on cloud as well as runs on-premise on hybrid environment in your data center. And finally, on the left-hand side, that you see operations tools like couple of things which are very important is like the logging, monitoring, error handling, alerting, debugging, profiling. So all of these things are for the operations side. Plus, you also have got to consistently manage and maintain your clusters all across a multi-cloud and a hybrid cloud environment. So you've got policy controllers and config management tool to which is again based on some open source technologies like Gatekeeper. So that kind of covers managing the clusters all across the cloud. On the right hand side, what you see is that open source platforms or technologies that talked about. So many of these things that you see are actually created by Google and then in open source. Tekton, Istio, Knative is a serverless environment that we have, and Kubeflow is for writing pipelines or machine learning pipelines that basically run in a cloud native environment. Along with that, we also have few programs, or processes to actually help customers discover, their environment. Stratozone is one of them. Both infrastructure as well as platform can create, TCO ROI for your, cloud movement. We've got Dora, which is a tool that or a framework that basically helps us evaluate a customer. They themselves can evaluate, their teams and how mature their team are with respect to their maturity with respect to DevOps and the agile practices, and how fast and how stable in code they can create, and how do they basically compare themselves against the elite of the world. So it's basically a scientific research based on 30,000 customers that we have interviewed, and a framework that exists that basically help us evaluate customers, find their gaps, and then also help use Google Cloud to bridge those gaps. Camp is another a little more elaborate a program that is for more customers who are really very serious and large scale application migration to cloud, what they're doing. So we support that as well. Now, what does it actually really mean? It means that we basically are able to help you with this entire DevOps cycle that you see, right from planning all the way to monitoring stage, and every stage of this cycle, whether it is writing the code for a greenfield project or migrating an existing code, doesn't really matter. Once you are in a new environment, you need to maintain it going forward. So it doesn't matter how did you come through cloud migration or through writing the code or building it. Then we support in the build phase through some of these tools, like mostly the cloud build, and then the package registry that I talked about, safely store it in a cloud environment for those applications that you write. But then there are many applications to complete your software supply chain. You need to basically also use some of the open source products or paid products from the marketplace, right? So securely, get those RabbitMQ or MongoDB or any other open source project that you want. And then this is the focus area for today, where in the second half I'll talk about the serverless platform. So this is the platform once you have your code packets ready where you want to run it, and finally once you have gone to production, these are all the tools in the cloud that basically helps you keep your lights on always. I think with that I'll pass it on to Srini. I'll come back again for the service. Srini.
Yeah, thanks, Ajay. So I'll go and share my screen.
Yeah.
So you will see it, right?
Yes.
Okay, cool. Yeah, good evening, everyone. Again, as Raju said, thanks a lot for joining on a Friday evening. So hopefully we'll try to keep it short, interesting, demo-driven, and you will have something to take away after this session. So what Raju covered earlier is more about an overall application modernization portfolio in Google Cloud, right? So what I want to cover in the next, there are two parts of the session that I'm planning to cover. The first 10 minutes, what I will do is cover some of the new releases and new features that got introduced. Typically, we have quarterly releases within Google Cloud. So I wanted to talk about some of the latest things that you can leverage in your journey, right? And the next section, what I will talk about is with Google Kubernetes Engine, when you have multiple Kubernetes clusters, I think if you look at it, Kubernetes has become more or less the foundation on which you deploy the applications, right? And it has become the de facto orchestration platform. And a lot of customers now are using Kubernetes in production. And when you start using Kubernetes in production, and when you have multiple Kubernetes clusters, what are some of the things to be taken into considerations? So I will do a quick demo around it and kind of showcase how you can think about managing multiple clusters, right? So those are the two sections. So let me first talk about in terms of what are some of the new things that we have been doing in Google Kubernetes Engine. So for like Raju mentioned, right, Kubernetes Engine is our Google Kubernetes Engine is our managed Kubernetes service offering, and it has been in general availability for the last 5 years. And I would say very advanced from a lot of aspects, including performance, scalability, usage. You can create a cluster within, let's say, less than a minute, right? It's pretty very user friendly from that perspective. So what we did recently is that we launched. So we launched this something called as a GKE Autopilot. It's based on all the lessons we have learned using Google Kubernetes Engine in the last 3 years. I'll talk about it in the next slide section. We've also done some enhancements. When you have seen it, typically in a Kubernetes cluster, right, you have service discovery that happens within a single cluster. Now, when you have multiple clusters, how do you extend your service discovery across multiple clusters, right? So we have something very unique in Google, which we call as multi-cluster services. So that's a very interesting concept, when you want to talk about services operating across many different clusters. We also launched something called as a GKE data plane. We call it as V2, but it is based on an open source standard called as eBPF and Cilium for folks interested. You can go and look about it. But mainly what it is targeted towards is think of it as a very high-speed data plane without using IP tables. For folks who have looked at Kubernetes data path, right? A lot of things happen through IP tables. With this new data plane, we have done some of these forwarding at a much lower layer so that you can get much higher performance with it actually. And few other things we did, let's say for example, what we found is when customers have many services in their cluster, the service discovery cannot scale beyond a particular point with what Kubernetes service discovery works, right? And we have integrated GKE service discovery with Cloud DNS. So from a scale perspective, it is very highly scalable actually. So basically, if you look at some of the enhancements, some of them are from a usability perspective, some of them are scalability. That's the themes that we have used, right? So let me talk about Autopilot in little detail, right? So if you look at GKE Autopilot, it's an evolution, right? In the sense is, okay, let me start off first with why would you need a managed Kubernetes service, right? Typically, if I'm not sure if any of you folks are using self-managed Kubernetes, right? If you are using self-managed Kubernetes, there are a lot of things that you need to take into consideration, right? Including control plane, data plane, security networking, patching, scaling, monitoring. All of these are aspects that you would need to take care. And Kubernetes would provide obviously the control plane, right? But you need to take care of all these things by yourself, right? And what a managed Kubernetes service provides, and whether it is GKE or let's say you've taken Azure AKS or AWS EKS or any other service, right? Now they take care of a lot of these aspects, but the two aspects you still need to take care is your worker node management and your security and networking configuration. And what we realized over the years is as more and more customers are starting to use Kubernetes in production, this also becomes pretty difficult for customers to do this at scale. And within Google, everything runs in containers, right? And we have observed some of the best practices, both from an auto scaling perspective as well as from a security and networking perspective, right? So we thought, why don't we provide all the Google's best practices and learnings into one platform, which is much more, we call it an autopilot. what it really means is, you take your managed Kubernetes and run it in an autopilot mode where it is using all the Google's best practices, right? So that is the theme with what we've done with GKE Autopilot. You can use the same Kubernetes manifest file that you have used. Nothing changes from how you interact with the cluster. It is just that the management of even the worker nodes and security networking, all those aspects are also handled by Google Cloud, right? So what does it mean to you, right? One is, all the best practices are integrated. Second is, auto scaling, right? I think Google has one very unique thing. We call it as a 4-way auto scaling. You would have heard something like horizontal pod auto scaling and cluster auto scaling, right? We also have something called as a dynamic scaling or dynamic resizing of the nodes based on the type of workload, right? So basically all it means is how efficiently can you use your cluster, right? So that's kind of what we're talking about here. Second is in terms of everything is monitored by Google, and if there is any patching, upgrading, all that is automatically integrated. The last part which is interesting, which I find a lot of customers liking it, is you start in a typical Kubernetes cluster, you pay to Google based on the number of nodes you have used in the cluster, right? Even though you are not using the nodes, you would still pay for the nodes, right? Because you have created a cluster with the nodes. So what the model with this autopilot is, we will start charging you per pod, right? So if you have a workload running in the cluster, you will pay to Google, right? If you don't have workload running, you will not pay for it, right? So this model is extremely flexible because it's really targeted towards you just pay for what you're actually using, right? So those are some of the advantages of autopilot. Again, I'm kind of going through it at a very fast pace, but if you're interested, you can start looking at it deeply, and again get back to us if there are more questions. And there is also a Q&A session at the end, and if there is any questions, we'll take it up there. The next thing I want to quickly highlight is the updates on Anthos, like Reju covered, right? Anthos is our hybrid and multi-cloud platform for application modernization, and it is built on top of Google Kubernetes Engine, right? And again, we have a very quarterly release of Anthos. The last release was Anthos 1.8, which got released last month. Again, there's a lot of features. I picked, I would say, the last top 5 features. And again, I won't have time to talk through each one of them, but I will maybe highlight 3 of them, which I think is, which I like, which I think would be useful, right? First is we have something called as an Anthos unbundled mode available for Google Cloud. So what it means is, earlier when you purchase Anthos, you would kind of buy the whole package, right? Including all the features provided by Anthos. Now, what the option we give to customers is, you can pick and choose the capabilities that you're more interested in, and you just pay for that, right? So it is much more flexible from, gives much more freedom to the customer. The next one I want to quickly talk about is Anthos on Azure. So if you look at the way Anthos, the platforms we started supporting, right? Initially we did Google Cloud, we went to on-prem, we did VMware, we did bare metal, we did AWS. Now we have added Azure also to the portfolio. Basically, what we want is, our goal is, have not dictate where the customers have to run the workload. You can run it on any cloud provider or any on-prem, but can we have a common control plane, a common dashboard to manage, right? So that's the goal with that purpose. We also did one thing with respect to Anthos Edge profile. What we understood is a lot of the customers who run Anthos, right? They're running it on locations where they don't have a lot of compute resources. Think of like a telco edge or a retail edge. So we wanted to run Anthos in a very minimum footprint, so that even if you have, let's say, a one VM with, let's say, 2 to 4 vCPUs, can I run the complete Anthos in the edge, right? So that is what the edge profile is targeted towards. Very lightweight platform which you can run your workloads on, right? Yeah, think of more edge use cases that would be applicable for this Anthos edge. And there are a lot of other scale enhancements. I think I'm going to skip some of them. Yeah, so this is primarily what I wanted to cover. I think I'll skip this part, not that important. Okay, so this is this section. What I covered earlier is more about what some of the latest things. What I wanted to cover in the next 15 to 20 minutes with a demo is, as I talked about, when you have multiple GKE clusters, what are some of the important things to take into consideration, and how do you manage them, right? So that's kind of what I will talk about here. So in this diagram, right, what you see here is I have few GKE clusters running in, let's say, one region, and few more clusters running in another region. And think of, to keep it simple, right? Think of this is Mumbai region and this is a Delhi region, right? And the reason I'm mentioning is we launched the Delhi region a few months before. And by the way, we are the only cloud provider in India with 2 regions, and each region with multiple zones, and the 2 regions being seismically separate, right? And that's a very big requirement for folks like banks, where they want to have their DR in a totally different seismic zone region. So yeah, so think of this is Mumbai, this is Delhi, and your goal is your customers coming in through the load balancer, and they want to select a cluster close to where they are located, right? Say, for example, you have customers coming in from Delhi region, they want to go to Delhi. Customers coming from Mumbai, they want to go to Mumbai, right? And think of a use case where latency is very, very important to you, and even things like 20 millisecond or 50 millisecond makes a big difference, right? For those use cases, as you know, Google's load balancer is global, and using this thing called as multi-cluster load balancing, we are able to achieve this proximity-based routing, right? So this is from a data path perspective. The next thing I want to quickly talk about is, so you have multiple clusters. Think of it. Let's say you have few clusters in Mumbai, few clusters in Delhi, and you want all these clusters to have central policy, right? And that is what the policy repository helps you. So what you can do is you can put all your Kubernetes policies in a single repository, and whenever there is a change in this repository, it will get pushed to all the clusters. And we have an operator running in each cluster, and this operator will pull in the policy from each, from this policy repo. So which means, think of a scenario where if I have 5 clusters, right, 5 Kubernetes clusters, I never have to go to each cluster to manage things. I can push all my policies to a central place. It gets pushed to every cluster, and you know exactly what is running. And this is typically the philosophy people use with GitOps, right? You really know what you're running. You don't want to have a snowflake configuration in your environment, right? So that's very useful from that perspective. The last thing I also want to mention is, okay, now you have, let's say, applications deployed in Mumbai, you have applications deployed in Delhi, right? Now you want to talk between these regions, right? For example, you have some servers running here in one region, and you have some servers running there, and you want to talk east-west, right? And typically you use something called as a service mesh. Service mesh is what provides you service-to-service communication in a secure manner, and it is one of the most popular open source projects is called as Istio, and with what we call as an Anthos service mesh, which is a managed Istio, we are able to do east-west communication. So I'll talk some of these points in little detail, and then I'll go to the demo. So yeah, so I think very briefly, Anthos service mesh, I talked about it, right? So it's useful for, if you think of service mesh, useful for 3 reasons, right? One is like a traffic management. Think of things like, if you want to do a canary release, if I want to select a service based on the user, if I want to do circuit breaking, where you want to have much more control over the traffic, right? Then you use something like a service mesh, or when you want to have TLS-based communication between the services, everything should be encrypted between the 2 services, right? So those are scenarios where you use service mesh. And what does a lot of people ask, right? Why should I use Anthos service mesh compared to Istio, right? The main reasons are, it's a managed control plane. The analogy is you have open source Kubernetes, you have GKE. Similarly, you have Istio and you have Anthos Service Mesh. So it's a managed offering. So which means the control plane, right, doesn't even run in the same cluster. The control plane is running outside the cluster, managed by Google. So we will take care of Istio upgrade. And for a lot of people, upgrading Istio is a pain. And that is something Google can manage. And also what we offer is something called as a topology and a SLO dashboard. So let's say when you have a lot of microservices deployed, right? You can see this nice topology view that will tell how the services are interconnected, how much is the traffic flowing between different services. If there is any problem, it will highlight, okay, there is a problem between the service, right? It gives a nice diagrammatic view of how your services are communicating to each other, right? It's a very nice, I would say, debugging tool. And you can also set up things like alerts. So when there is a failure, you can automatically get alerts when one of the servers is misbehaving or something like that, right? Right. So yeah, I talked about policy controller. So I think when I do the demo, it will be more clearer. But I think I'll maybe show that in the demo itself. And this multi-cluster ingress, I talked about it, where if I want to do global load balancing between multiple clusters. But I think all these three things let me talk through in the demo. So this is the demo that I'm going to do, right? So what I have already deployed is this particular topology. I have a GKE cluster that is running in US. I have one more GKE cluster running in Europe. And what I have done is tied them through this global load balancer. And I also have Anthos Service Mesh installed. So this is the gateway for this service mesh. And from an application perspective, I have two services deployed. One is called as a where am I front end, and it's a container which basically tells where I am running, right? Which particular region I am running. And then there is a backend service which will also do the same thing, where this particular service is running. So I have deployed this service in both the clusters. And I also have installed Anthos config management, which is the policy controller piece, right? So let me first start off showing. Is the font size readable, or should I make it a little bigger?
It's all good.
Okay. Okay, so what I have also done here is I have created two instances to, let me first show my console. So first, let me start off with showing what are my Kubernetes clusters running. So here, if you look at it, there is a cluster that is running in US Central, and there is one more cluster that is running in Europe, right? So these are the two clusters that is running. In addition to that, what I've also done is in the same project, I have created two instances. Let me show you. So these two instances I'm going to use to send the traffic, like the source of the traffic, right? I think if I show in this way, it will be easier. So basically, the source of the traffic coming from either America or Europe, and going in the backend, it will go to either the two clusters, right? It's a US cluster, and then there is an Europe cluster. So this is how the flow is going to be. So yeah, if I go to my VM instances, there is an Europe instance, and there is a US instance, and these instances that you're seeing, right? Those are the instances associated with the Kubernetes cluster. So I have logged into this instance. So what I will do first is I will generate some traffic from each instance. I have some cheat sheet here, so I'm going to use that. So first I will generate the traffic from the US instance. Okay. So now what you see is two things here, right? So basically, there are two results you see. One is something called as a backend, and another is something called as a front end. So what it means is this is a front end microservice, and this is a back end microservice. Going back to my picture here. So the picture here. So basically, I talked about two microservices, right? This is my where am I front end, this is my where am I back end. So what all this service is going to do is this is the front end service. It's going to tell where this endpoint is coming, right? That's what it is trying to show. And if I go to Europe, I'll do this. I'll show you the same thing. So initially, when we don't do anything, right, what will happen is the traffic from US will go to US, and the traffic from Europe will go to Europe. So that's the flow it will be. So here, if you look at it, the traffic from Europe is going to Europe, and the traffic from US is going to US. So what we will do as a first step is we will basically try to trigger a failure of this US, and when there is a failure here, the traffic will fail over to the Europe cluster, right? And that's the first thing that we will show. So to do that, what I'm going to do is, so basically I'm going to do a failure of the health check, and I think you can do it in different ways, but I'm going to do it that way. So let's keep the US cluster running, and what we should see is the US should go to Europe, right? The US should change to EU. So I have basically failed the health check here. Okay, so now if you look at it, both the endpoints are hitting the Europe endpoint because I have failed the US, right? So the failover has happened from US to Europe. So basically, the customers coming in from US, they would also go to Europe because the overall cluster there is a failure in US region, right? So that's the first. So basically, the first use case I want to highlight is this handling the region failure. The next one I want to quickly talk about is I've talked about east-west communication, right? Where a service in US can talk to Europe, or a service in Europe can talk to US, right? And how does that happen? What we do here is we call as something called a multi-cluster ASM or a multi-cluster service mesh, where the two clusters can talk to each other and communicate to each other, right? So how do we do that? First is we will initiate what we call as a cluster discovery. So I'm just going to, I've already done this. I'm just going to paste it here. So when I do this cluster discovery, what you will see is the two services can talk to each other. So the front-end US service can talk to back-end Europe, and the front-end Europe service can talk to front-end US. So currently you see, both are EU here. And after I change this, you can see that the EU can be talking to US, other way around as well. So basically there will be a round robin load balancing that would happen. And now you can see, let's say, I'll show you one snapshot. Okay, let me show you this. So if we see here, there is a front end coming to Europe and then going to a back end, which is in US. So the flow is like this. When you see that, this particular flow that I'm showing, right, what happens is the traffic, when it comes from the user, it comes to Europe, And then this particular gateway is going to load balance to Europe as well as to US, right? And that's typically how it will work by default. And this is not good sometimes, right? Actually, it's good sometimes and it is not good sometimes. Where it is good because you really need communication to happen across regions. And where it is bad, there are some services which are very latency sensitive, and you do not want them to communicate across the clusters, right? And those scenarios, it is bad. And the way you can prevent that kind of a scenario is you can use something called the locality-based load balancing. With that, what you can do is when a traffic enters a particular region, you can enforce that the traffic stays in that particular region, right? So that is, a way to do that. And I think I can show that to you as well. But I think we are running out of time. But let me just quickly try that. Anyway, I'll skip that part for now. But think of this way, right? Where you have inter-region traffic. As I said, sometimes it is useful if you want to prevent it. You can, turn on locality-based load balancing and prevent the inter-region traffic. So last thing I wanted to quickly highlight is the central policy management. So let me show you the Anthos user interface, right? So here, okay, just one more thing I'll show before the config management. I talked about a service mesh topology view, right? How does it look, right? So if you go to the Anthos service mesh topology view, so here you can look at the two services, right? One I talked about, which is the front-end service, and the other is the back-end service. And you can look at, what is the traffic that is running between the service. And if you do an expand, so you can look at a service level, deployment level, pod level, and you can look at all the communication that is happening, right? So here we have two services, but when you have multiple services, it's easier to visualize that. Okay, so let me go back to the policy management piece. So what I have done here is both these clusters, I have pushed the, put a central configuration in this particular Git repository, and any changes when I make to this Git repository, right, from a Kubernetes policy perspective, will get pushed to both the clusters. So just to give you an example, so for example, now let's say I'm looking at the namespaces in one of the clusters, right? And what I want to do now is I want to create a new namespace. And typically, what would you do? You will go to the cluster, create a namespace, right? And that's a traditional way of doing it. Now, what if I want to do it in a GitOps manner, right? You want to push it to a Git repository and then make it automatically get reflected, right? So let me quickly show you what we will do there. Okay, so here let's say I am accessing that particular Git repository, and what we will do is we will create like something called as a workshop namespace, and quickly change this. So what I'm going to do is just commit this to the Git repository. And what we should see is it should automatically get pushed to both the clusters, because since both the clusters are synced to the same Git repository, right? Any changes that we make to this, it's a hierarchical policy, by the way, and that will get pushed into both the clusters. So ideally, we should see that workshop appearing here, hopefully. Yeah, so we can see that the workshop namespace coming up here, right? So this is a simple example, but again, you can have much more complex policies that you can get pushed across the clusters. And sometimes not just configurations you want to push, right? You might also want to push policies. So let's say, for example, think of so here I have certain, let's say when you're running Kubernetes clusters, right, you want to make sure that certain restrictions are there. For example, if you want to enforce a restriction to your users that they cannot download container images from, from repositories that is not allowed, right? You can set up a policy like that and push that policy to all your clusters so that your developers, right, when they use it, they cannot use any public repositories which might cause any security vulnerabilities, and that is what something like a policy controller would do. So just to give an example, one of the example I want to show you is, let's say, for example, you want to set a constraint to say that only allow these repositories, right? I want to allow repositories from GCR or Open Policy Agent, and I do not want to allow any policies from any other locations, right? And the way you can do that is very simple. So you can apply this constraint. Once you apply this constraint, it will automatically not allow any other repositories. For example, if I look at this is one of my YAML files, which is using an image from a repository that I'm not allowed, because I'm allowing only these two repositories. Now, let's say if I want to apply this one, you will get a failure because, so if you look here, it says that it is an invalid repository because I'm only allowing these two repositories, right? So these are certain examples of policies that you can enforce. There's a lot of templates that Google provides by default, and you can extend it to whatever use case that you want to extend it to, actually. So I think I'll stop at this point. And I think we already ran over by a couple of minutes, but I'll be happy to take any questions. So while the next session is going on, if you have any questions, please let me know. I'll pass it on to Raju. Thanks.
Yeah, thanks, Srini. Hope you're able to see my screen.
Yep. Yeah, sure.
I have double monitor. Can you just confirm that it is a serverless overview and demo? That's a slide. That's
yes.
What it's, okay.
Yeah.
Okay. All right. So quickly now we'll move on to the application development in the cloud. Okay. So specifically around serverless, a quick overview of the serverless market. A whopping $21 billion by 2025. That's what we are expecting it to be. I mean, it was 7 years back, 8 years back. I think our friends popularized serverless, but I think the future looks pretty bright. And yeah, and by 2025, 50% of the enterprises would have, would have in some form or shape accepted serverless technology. But let's understand what is the serverless computing model. Now there are basically two, school of thoughts, or two kind of people in this organization that deals with application development and then finally to release and operations. So let's look at the operational part of that. So first is like it's a misnomer to say that it's serverless, that it doesn't require server. Of course, it requires some server. So that's where the compute happens. But the management of that servers are not a headache of, let's say, the operations team. The fully managed service normally provided by a cloud provider. All the hyperscalers have some other form of providing a serverless solution. There are other aspect of it which makes it very attractive for the customer is the kind of billing, which is similar to a utility billing, a pay-as-you-go or Apigee billing. Interestingly, that at least at Google Cloud, that is checked every 100 milliseconds. So it's a sub-second billing that makes it very attractive, because if for the next second, if you're not using it, you don't pay. And also there's a concept called scale to zero, which means again, if you don't have a request coming in and hitting in your application, then you actually pay zero for for that amount of time. For the developer side, and developers, it's also providing actually a programming model, right? Yes, the serverless solutions that Google has is created on top of Kubernetes to be the kind of layer, but that layer is not visible to the developers. So the developers can just concentrate on what they're best at, which is developing code, and don't worry about anything else, because they want that this is my code, go deploy it to the cloud, I don't care how. So that is what, and the pattern actually goes into identifying the workloads that can be horizontally scaled, and that's where the statelessness comes in. Not every application can be moved to a serverless model. It supports both the programming paradigm, which is the request response, as well as publish subscribe, which is event driven, and it is built on top of a open source framework, which Google kind of spearheaded it within Google, and that is called Knative. So Knative is kind of just like Kubernetes is becoming the de facto, or has become the de facto standard for orchestration. Knative is becoming the standard for abstraction or doing serverless on cloud native environment. But serverless for us is more than functions, and that's how our friends had actually brought serverless to the market. It's like you just write some functions, and for a very small life of that function, it's got a context, you got a message coming into the method, and then you got some processing happening and some output going out to the method. So that is how a function was written. But for us, serverless is a little bit more bigger than functions, and what they are, they basically support use cases which are far more than a function as a service. So for example, this is our serverless portfolio. Now on the left hand side that you see is the build and the run. That means you can build applications using Cloud Run, which is our more recent I think 2 years back it came to market. So that is the first one. Cloud Functions is another one. So yeah, here we support function as a service, but that's not what we call serverless. This entire spectrum of things that you see is what serverless for us. And we build serverless applications, we see in the demo. And then of course, Cloud Build is the CI/CD, the Tecton, the first slide of mine, which had a cloud native build. How you basically create a pipeline as code, and you write composable declarative pipeline separate steps, or basically using a YAML file, and then Cloud Build basically automatically takes care of the kind of load that it comes in the form of the jobs. And if you are familiar with the Jenkins of the world, you would know that you have to set up a Maven configurations one page, you have to set up a JDK on another page, you got your plugins on another page, and you got your code jobs running in some other page. Very complex. So pipeline as code is a simple YAML file written as just one thing, source controlled. It really promotes the cloud native development and deployment, and it actually runs on top of Kubernetes itself. The second part of this one is basically the orchestration part. So while these serverless units, they all are there to solve a particular problem, but then more often than not, they need to connect to each other, and they need to basically pass information and exchange data as well. So that's where the cloud workflow comes in. It's very amazing. In fact, I came to know about it quite late. So this is basically orchestrate your serverless units in the cloud. Okay. Then you've got event arc, another mechanism by which you are able to pass or take the benefit of event-driven architectures or event-driven applications that pass on event, and now you don't need to really have your own some sort of a queuing mechanism like a PubSub or any other queuing mechanism to kind of hold it and then pass it on to the or to subscribe to another service that you have. It basically the services can actually talk to each other directly. And then you have Cloud Scheduler, which is basically cron job in the cloud. App Engine, like I said before, the oldest of our application. It was a past service, I would call it. 10 years back it came, but it was a serverless 1.0. What we are now Cloud Run, or the serverless 2.0 is what you can call the re-Christian or the more recent one. And you also have the connect. That means you need to connect. These are serverless stateless applications. Stateless application obviously will only make sense if you have just really stateless application. It's very difficult to actually imagine a world like that. So you do have state, and for which you need to connect to the state, like the databases, caches, and the queues. And for that you have one mechanism is like the PubSub, and the other mechanism is through a serverless VPC access. That means you can connect to a database or MongoDB or a Cloud SQL. You connect it via a serverless VPC. And then finally, if you have some services that you create, an API that you created, and you want to expose it out under a certain specs like Open API standard, and put some basic constructs like expose it out to to another, let's say, service, we can consume it. I would say very rudimentary way of, let's say, exposing, but quite okay for customers who just have a simple requirement. For other complex requirements, Amarnath is there. We'll talk about Apigee. So when to use what, right? So that's always a confusion. So use Cloud Run when you're developing web application, and also HTTP services, because it's basically they are typically an HTTP endpoints, and which which basically gets triggered by either a different service calling this service, or actually a customer calling an endpoint URL for like a web application or an API. App Engine is another alternate, but I would propose App Engine Standard, which is more like a sandbox environment and supports like again scale to 0 as compared to App Engine Flexible. If you have a requirement of App Engine Flexible, go with Cloud Run. The difference between App Engine and Cloud Run is that Cloud Run can support containerized workload. In fact, it only supports containerized workload, and that's where we want to go. App Engine supports a typical path in which you just got a folder in which you have an application. You don't have to drop in a Docker file to kind of to run it. It can actually do without it. Cloud Run is also good for APIs. It has 60 minutes right now. I think we started with 15 minutes, but now 60 minutes. So if your HTTP response comes back, the request response comes back within 60 seconds, any work that you can do within that 60 minutes, anything that you can, any kind of workload that you can do in that 60 minutes is a good workload for you, which also means that we can use Cloud Run for also creating jobs, data ETL jobs or any kind of jobs. So just imagine now, think about it. Are these like, functional service? Are these like serverless? It's much beyond that, how our friends define it. And also we have now this orchestration, there are different mechanisms by which you can do orchestration and connect these services together. And I think I'll skip it for yeah, okay. So this is basically, there are three things on the orchestration side of thing, right? So event arc I mentioned, asynchronously you deliver events from different cloud services, whether it is a bucket, whether it's a PubSub, whether it is a machine learning or Vision API or any of the services, right? And workflow is the latest one. It's literally, if you're familiar with the drag and drop compose kind of where you have a canvas and you just drop elements from a canvas and you start drawing if else conditions and try and catch and those kind of things. So that you can do it on the cloud. Of course, we right now don't have a drag and drop feature, but you have a support which is very similar to I've seen it in a previous competition. They had this where you have got on the left hand side you've got a YAML file, and the right hand side you've got the graphical representation of that. So either which way you can edit those things. And then you finally have the scheduler, which is like good for just running a cron job without the hassle of actually running a job. Just put a cron pattern and it will take care of it. So that brings us to the demo time, and the demo that I wanted to do, and be mindful of time. So I'm probably not going to do a live thing. I just walk you through this whole thing, and with maybe the final output of the demo. So what we want to build actually is a microservice application. But what we want to do is we want to build this microservice application using different serverless components. So we want to use Cloud Functions for something. We want to use Cloud Run for something, and we'll probably use App Engine for something. Okay. So the use case is let me actually show you. Let me walk you through first how it looks like. So this is a demo. So it's okay. Yeah. So Srini has been very grateful to give his project to me, and I'm using that right now. So this is basically a pick a day serverless application. So that means it's an application that will help us just take pictures and upload it in a website and share it to others. But before you upload this picture, you want to make sure that this does not have content which are not appropriate for everybody. So you want to actually do some sort of a vision analysis on this. You want to know exactly what this picture is. Does it have anything which is not appropriate? So you take that thing out, or you could also use it as a label. You can extract out certain label and then use it for a metadata search. For example, this is Qutub Minar. So this could be a building with a tall building, and at the same time this is a lotus. It's called in Australia, right? So yeah, something like that. So it will have its own property, right? So that two different types of buildings, and they're different colors, everything different, right? So extract out those metadata, which is basically where we are going to use a Vision API. So we can call the Vision API. So let's actually see how it is. I hope it works. Oops, sorry, I need to choose a file. So all right. So I think let's go with Hawa Mahal. Okay. So this is in Jaipur. I've been here. Very nice place. Okay. it didn't work. Let's see. Okay. Okay, let me see what really happened. Okay, so what we are expecting it to happen is, as soon as you hit the application, this is the application that you saw is hosted out of an app engine. Now, the upload button that you see actually takes out that image and puts it into a bucket, a picture bucket, which is, we call it as an upload bucket, and we'll see why it didn't work. And then as soon as image is put into the bucket, you've got a trigger that basically there's a topic, and to that topic, that particular image basically has a trigger that anytime an upload happens, a message is sent out to the PubSub. The Cloud Run service here has got a subscription to the notification that is defined on the on this particular subscription. So the Cloud Run service is notified, that goes and fetch this particular, and this code is actually written in any language that you want. Like, and so in this particular example, it is Node.js, and it basically goes and fetches that that particular image from the cloud storage using the client API. So here you got Node.js APIs for cloud storage, which basically goes and pulls that thing out. And what it also does is, if you see here, from this bucket, there is also another event that is triggered, which is basically a cloud function. Okay, so this is the cloud function, and the cloud function makes use of the Vision API. So the Vision API basically extracts out that those labels and basically stores that labels into a file store database, so that you can search for elements at a later point in time. So there are a few elements used here, but the serverless component of first one is the cloud functions. So where the idea is, like, for every image uploaded, there's a very small activity that you want to do. It does not need to be long running, and you can finish it up as soon as you have basically an API call that you do, which is going to basically use that input to search against a data set, which has got a predefined set of what are things for it, like a building or a cat or a dog or whatever it is, and it basically gives you as a result, it gives you some of those things, and then you store those things also in a NoSQL database, which is a picture metadata file, so that you can search those content later on. So this is basically the cloud functions part. Then the thumbnail. So there's another service here is called the thumbnail service. So as soon as you put a large picture here, it converts it into a smaller dimensional rendition, and that rendition again the metadata is extracted and put it into the file store. So this is implemented as a Cloud Run service. And then finally you have another service, which is a image service, it's basically a GC service, which is a garbage collection service. Basically, when you go and delete the objects from the cloud storage, you basically invoke this service, which is going to delete this application, delete the images from the from the application that is supposed to be. It should actually have come. Let's see what happens. So when I inputted this application, if you see, ideally, so this is the cloud function that I just mentioned. Okay, so I think we're not getting into the code too much here. Just think about it like this: that you get the request and response. You basically fire an API call to your image search. To your Vision API, and then you basically get these results, whether it's safe or not, right? Now, if you see the logs, we will try and understand why it didn't work. Okay, so I think we put.
Hey, Raju, I see the image appearing. So maybe it was just a cached thing.
Is it a cached one? Okay, let me see. Yeah, that was a problem actually.
You want to try refreshing once?
Yeah, let me do that. I'll do a force refresh.
Can you go to the home window?
Yeah. Oh, okay, great. Sorry, thank you. Sorry, it was having a big embarrassment, but yeah, actually it came in here, right? So the use case was like this: that as soon as you upload an image, a small thumbnail would be created, and that thumbnail with the extracted data that you see here, the sky building, it's a temple, it's symmetry, all these things are actually getting extracted from our Vision API. And this was the call that the function, the cloud functions did. Okay, and similarly for other things. Okay, there's another service here called collage service, right? And the collage service, what it does, I think probably it also has the same problem. It's the cache thing. Okay, maybe what I'm going to do is.
That one also works fine. Yeah, it must be the cache as well.
So I think, I mean, for now, you just trust us that it works and it's a caching problem. Yeah, so what it is supposed to do is, as you upload an image, it would create a collage of all of them and create a new image, and that image is called as a collage.png. Okay, and if we look at the code from here, it basically puts it back into the cloud storage. Okay, so if I look at the storage, okay, I'm going to maybe use one of these quickly already. Okay, so this is the storage. So this is the buckets that we have. Let's have a quick look at the buckets. So this was the bucket upload picture. So this is the bucket to which we were uploading the content. So as you see, we had two initially, and then when we uploaded an image from the UI, the Hawa Mahal, that it came in here. Okay, but as soon as it came in here, you'll also see that there is another bucket, which is the thumbnails bucket. Okay, so this is the bucket where the thumbnail gets created. So if you see here, this is a much more smaller version of this, and this thumbnail is actually getting created by this service that this service, thumbnail service, which is actually running as a cloud run. As you can imagine here, both of these activity are happening based on a certain trigger. So in the first one, if you see, this is a trigger it's a creation trigger. That means when your object get in a bucket, if you're familiar, and the object get finalized, at that event, basically this trigger happens. At the same time, when a particular object is getting deleted from there, that's when this event happens, and that's where the garbage collection service runs. Anyway, so coming back, and there's another feature of this which is again implemented as a cloud run service, and let me show you the service quickly first.
Okay, Raju, just a quick time, maybe a minute or two if you can do it. Thanks.
Yeah, oh sure. All right, I'm gonna maybe finish up in 2 minutes. So this is the collage service, and this is running as a cloud run service, fully serverless. It has got this endpoint, which basically is a trigger point, or this is how the notification service may be have this this address mentioned, and that's how this particular service gets invoked. And yeah, and just if you see the logs here, you would see that this is also processing those object, and I'll actually point you to the entire exercise. You can do it yourself, and let me just go back here quickly. Okay, so these are two services as cloud run services we are deployed, and sorry. Okay, what else can I show here? Okay, there's another thing. That's collage itself. The service, I mean, this collage itself is triggered using a scheduler, which is I mentioned that there are certain services which basically help us orchestrate. So this scheduler basically runs every minute, and it takes in all the images that is present in the directory, and in the upload directory, and actually creates a new image called collage.png. So what it does is it takes these 3 images and creates a new image called collage.png, and this is also actually created as a separate service. The thumbnail service or the Cloud Run service is basically this service, okay? And there are a few other things. One last thing that I want to basically show, the messaging that I wanted to basically give is that in Google Cloud, you can use different cloud services to do different sort of things, like the Vision API thing, the function service for doing your image conversion. You're using a Cloud Run. Of course, I'm not showing you the code for it right now. It's just simple Node.js application with some sort of API that converts an image from one size to another size. And so the last thing that I wanted to basically show you is the and Srini, I'm aware that we're running short of time. This is the workflow that I mentioned. You can actually orchestrate whatever diagram that you show, that you're seeing. You can actually create that workflow in this format. This is what I was saying. Okay, this is the new addition to in January this year that this came in. So you can have those if-else conditions. You can put those entire entire sequence of events that you have in your microservice that you're creating. You can either script it, or you can create it using a GUI like this. I think with this I'll stop it. Maybe I can hand it over to the next speaker.
Hello.
Yep, Amanat, go on.
Yep. Hey, Reg. Thank you so much. All right. So thanks everyone who stuck around. And the next topic that we have is, let me quickly share my screen on that. Please let me know if you're able to see the screen.
Yep.
Yeah. So we did have quite a few things for Apigee, but in the interest of time, we will keep it really short and go through the actual essence of what Apigee is, and we probably can look at it in detail in another workshop, right? And all right, taking a breather there. Okay, so even before we start talking about Apigee, right? So quickly going through why would you want, because there is already an API management gateway, but why would you want a standalone product which would manage your API management? Is for the reasons that you're able to see on the screen, which, let's say, if you want to develop an ecosystem and have a proper engagement with your customers and partners, in a very customized way, which we will go through, like the policies and other customizations that we get to manage your APIs. That would be one reason. And like it does have a great time to market and security as a layer when you have a bunch of API services, and the customer experience that you get when you are trying to onboard certain customers onto your platform, which is basically a whole set of APIs. That is also very unique when you are using or employing Apigee as a product on your service. And also it opens up new revenue channels for your product or the API services that you might be creating and possessing already in your business, right? So the best people that are most benefited to use Apigee as a platform is, you already, let's assume like you're a bank, right? Let's just stick with one example. And then you have a whole set of APIs driving your business. And then you have an application which is also like front-ending your business, right? And you would like to, you already are running a business using your internal APIs and your banking as your core business. But now, for example, you see applications like in India, we have Paytm, we have Stripe internationally. So all these payment gateways, the way they operate is by leveraging the services which are provided by these kind of institutions, or like you could say organizations which already are working like internal services. But how would you provide those services to such organizations is through APIs, right? And this not only runs your core business, but also provides you with new revenue channels, which a lot of other products and customers can make use of. And to track and to make that happen is where Apigee excels at. So, what Apigee offers in general to you and to the custom to the user of the Apigee is generally like one is an experience. When it says connected experience, it come across it does have many things. Like for example, the first thing, there are a lot of policies that become a third layer on top of your API collection, which deal with ideally collecting your APIs in some logical products so that those logical products can be connected to a certain group of users who are authenticated to use your application services. And there also exists a security layer in the middle, which are also governed by a lot of policies as to who can access and what is the level of access and what is the quantity of, like like there is a quota policy, like you want to kind of categorize your sets of APIs into products which are certain roles of users can use it, and customers who are registering to use your API services need to access in a certain restricted way, and probably you can use monetization over that so that you know who is accessing from which geography and your users are tracked. Apart from that, all of these things are also made possible by a very integrated which comes out of the box developer portal, as you would say, which gives all sort of documentation about and the information about the API platform that you are trying to expose to your customers, right? And the other developers who are trying to utilize your services. And smart documentation will also go through what it looks like. It's just that all your APIs can be browsed through a single UI, I would say. And all of these things, the usage and other things can be, and what is the performance, it is a very inbuilt analytical service that Apigee provides, wherein all your developer analytics, the usage metrics and the performance metrics that are going on with your APIs are seen by either your business users or anybody, like let's say if a developer wants to view them on their end, where reports which are inbuilt, and also there are logs and custom reports which can be developed, right? And also the reason why you would want to choose a Apigee between, like amongst all the API management gateways that are available, is the way it reliably scales with respect to the customer base increase or decrease is something very similar to the how the serverless architecture that Srinivas was talking about, right? And the ease of use that is there is it provides a very integrated GUI wherein a lot of people who are not even too much into programming can browse through all the APIs if in the service, add policies and remove policies, and control that. And the number of features that it provides out of the box is, I would start from the bottom because that is the most unique thing which comes out of the box. And like it has inbuilt compliances to many of the services and the domains that we deal with. Like if you're a medical domain, say, it is very HIPAA compliant, and if you're a financial backed service, so it is also PCI compliant. So these kind of compliance adherence is the like comes inbuilt out of the box. And also like a developer portal comes out of the box where people can um, come together to see exactly how to register and utilize for APIs. And the most unique thing about Apigee is the speed at which you are able to leverage and go to market between like having the service on your application and how quickly it can be converted to a managed service, a fully managed service, so that your developers are getting on board and your customers are able to use your service in the customized way that you model them. And there is also a lot of security and other pattern recognition which you can um, utilize using Apigee, which like adds another layer of security over your API service, which does a lot of abuse prevention and threat protection. Let's say by default, like preventing any sort of a DDoS attacks and other security threats that you might encounter. The cycle, I would say, like what Apigee provides is features wise, you get to design all of your APIs in a certain way that adding policies, which are, I will skip all of these slides again with respect to time, and these are the kind of policies that you would get to utilize. For example, um, the best features that you are able to utilize is first of all the traffic management to your APIs, and from going out of your APIs, which gives you a quota, and so the which limits the number of users and the usage of your APIs based on the how much the subscription of your users are. We also have like something like a spike arrest, and in case of DDoS attacks that I had mentioned. And the caching policy is very interesting, which comes out of the box also. But if you just include a policy, for example, if there is a repeated access on your any group of your APIs, and you have implemented a caching application caching policy. So assuming a service on your end is taking 200 milliseconds each time to access your infrastructure and get back as a response, caching policy brings that same thing to around a single digit milliseconds, let's say 7 or 8, as because the caching policies do take care that the requests that are coming in onto the Apigee layer do not even hit your backend, but the database and the other managed infrastructure which comes out of the box with the Apigee with a Cassandra database which stores the responses and requests very temporarily, can respond from Apigee itself instead of going around circle with the backend. And here there's a list of all the other security protocols that are coming out of the box, and which can be just as a plug and play. You can see like it can be used in Apigee. And for mediation, it's more like services that are dealing with the transformation of the API requests and responses, which either you can transform out of the box, XSL transformations, or JSON to XML, depending on what is the format of your backend processing and what is it that you want to expose it to your users. And apart from that, a more widely used ones are, which gives you a lot of control over customization, is when you want to customize your transformations using any of the JavaScript or Python custom transformations that you want to implement, right? So, and also the Apigee, when it sits in as a mediator, it is not just for Google Cloud Platform. You could have your services be hosted on any of the services that either on-prem or any of the other cloud vendors or Google Cloud Platform. But Apigee is an independent product which comes where you're able to leverage any of your services and provide your services um, like across all the clouds. And if you are multi-cloud architected a service, and then the same kind of benefits are available to your partners and your developers who are able to leverage an API management. And this is a little bit of an architecture on how you can deploy your application. Let's say for there is a different mm, regions and zones that are when you deploy your applications using Google Cloud, which are applicable also to the Apigee management. And the API definitions and roles and system configurations are done on the Apigee management gateway. And the other API processing can lie across different deployments that you might have across regions and zones that you might have chosen to deploy your services on. Right. Let me skip this. And this is almost like a example of documentation of all the APIs that you have. And skip this. And yeah, this is all. This is all the different levels at which we get to see the security that API security are required, and where Apigee can support on every level, and what kind of security that it provides. So key management is a very essential thing that that Apigee takes care of, because any sort of engagement that we need to do with the services, uh, no amount of brute force or you know um, um, uh, that is, let's say even if it is attempted by any of the users, would get past the Apigee layer, because it always authenticates via OAuth, or the key management which you already might be using in your applications can be transformed directly to Apigee, so that the same thing can be used by your developers, right? And also, like, all the activity which is happening as analytics on your applications, or the developer usage, or the traffic inflow and outflow, there are all kinds of dashboards and insights that you can you make use of to just have an overall view as to how your API traffic has been used across geographies and across all your customers and usage that is happening. And yeah, and the business models that happen on monetization are different ways that you want to structure your services to be available to your users, is either revenue shared or fee based or freemium models that you can have, like how you want to monetize your services going forward. So I would say we did run through very quickly on what are the brief services on Apigee, and I think it is time. But if any folks who are interested in learning more deeply on Apigee and having a demo run through, please reach out. I think we should be able to take it up as an independent activity and go through these services in detail, which are pretty interesting. Like what is security, how you publish, how you scale up and down, how do you monitor and analyze your requests, and a brief on how you monetize. Right. Um, all right. So I would say, like, let's just wrap this session about Apigee here. And any questions, Reju, Srinivas, or I can take, and I'll leave it up to um, Anshuman or Reju to, conclude the workshop.
Yeah, you can if you have any question, you can maybe unmute and ask, or you can drop in on the form as well. I know it's a Friday evening, and sorry, but there's a lot of this tech stuff. It's a little complex. It generally demands a little bit more time, and we are so tempted to show you so many things in a short,
Yeah.
small time that
Yeah.
it sometimes becomes.
I did have a demo also prepared, so that, I mean, like, so that we go through how easy it is to set up APIs and, categorize into products, and how they can be, you can plug it into these kind of policies, and how easy it is to drag and drop and all the other things. But I do recommend, Riju, like, with the people that we are having, and probably with a wider audience, we can show them like how easy it is to set up in every uh, flow, inflow, and response request. Yeah.
Yes, the serverless demo is available in the code lab, and let me just give the link. It's called I'll share it here in the chat.
Yeah. Meanwhile, I would just want to thank Saurabh, Srinivas, Reju, and Amarnath for such an insightful session. And we do open the floor for questions. So if anybody has questions, you can post it in the chat. You can unmute and ask.
So just on that code lab, it's basically there are, as you can see, it is 6 labs are there. And as you build through the lab, you will actually start to use different serverless products and build that microservice. So it's really good. It's definitely a little time consuming to pack it in 10-15 minutes. But I strongly encourage you to go through this. And yeah, anyone who has a Google account or a GCP account can do this.
Yeah, I think we should wrap this up, and I think there are questions. I think there are different channels to reach us, and I think we can for sure reach that.
Yeah, folks, and also I would like to highlight, just in case if you have any of the use cases which you pertain to fall in either hybrid cloud, multi-cloud, serverless, any of those kind of categories where you have some workloads running at multiple locations, please feel free to reach out to the CS team, and we'll be more than happy to have detailed discussions around those use cases and help you with the solutions, how Google Anthos or Google Application Modernization Stack can really help you achieve that.
All right, then. Yep. Yeah. Anyone wants to conclude? Yeah. Maybe I'll let it see us conclude it.
Yeah. I just wanted to just once again thank Saurabh, Reju, Srinivas, and Amarnath for such a great and knowledgeable session. And everyone, please feel free to put in your questions. Otherwise, we are good to wrap this session. And in case you have any questions or you are looking for a one-to-one discussion, we are putting the contact details in the chat. Please feel free to contact us anytime.
Okay, thank you.
Thanks, folks. Thank you very much for your time. Have a great weekend.
You too, everybody. Bye-bye.
Thank you. Bye-bye.
Thanks, everyone. Thank you so much.